Hi, we are Team Fuel the Future, and we are on a mission to help clear the air with our product, WasteWorks, a special biofuel which takes the waste from plants and makes it work as a cleaner alternative to fossil fuels.
The use of fossil fuels is a widespread concern in communities all over the world, including our own. With their harmful side effects and limited supply, fossil fuels are not a sustainable long-term solution. If we remain dependent on fossil fuels, we will eventually run out unless we explore, research, and develop alternative solutions. We desperately need to start working now on a reliable, renewable option.
One promising alternative is biofuels. Looking at this solution, it overall seems satisfactory. It is renewable and cleaner for our air. However, biofuels have a significant drawback. They are typically produced using the fruit of plants such as corn, soybeans, or other crops that are crucial for feeding the global population. Using these crops for fuel raises concerns about food security and resource allocation. To address these challenges, we have taken biofuels a step further. Instead of relying on food crops, we have developed biofuel from invasive species and plant byproducts. This approach not only provides a renewable energy source, but also helps manage ecological imbalances and reduce agricultural waste.
For the testing portion of our project, our goal was to find a way to ferment crops and turn them into cellulosic ethanol. We started in October gathering a variety of plants including leaves from tomatoes, cauliflower, bell pepper, and invasive species such as thistle, lamb's ear, and mint. We then washed the plants and blended them to form a paste, then stored them in the freezer until processing.
Over the next few months, we researched how to process the plants properly. We took the plants out of the freezer and began to pressure cook them to break down the particles from the plant before we began fermentation. We cooled the mixture quickly with an ice bath to ensure no bacteria got into the plants, and so the glass hydrometer wouldn't break because of the heat. We then put our mixture into the hydrometer to test the density. Next, we used iodine to test if the mixture had any starch. If the iodine turned black, we knew there was starch present, but if it stayed the same color, there was no starch. Next, we added the cellulase and then the amylase if there was any starch detected, and cooked it at 120 degrees Fahrenheit for 24 hours. After the mixture had been sitting, we did the hydrometer test again. We then added yeast to the mixture and put it into a jar with an airlock system for 7 days to help the mixture ferment. We then did the hydrometer test one final time and recorded the results. All of the plants displayed a successful result except the chocolate tomato plant and the thistle. We knew our testing worked when the density of the mixture went down, since alcohol is less dense than water. We calculated this by putting it into the hydrometer. This is as far as we could go without getting a distillation permit.
After conducting our tests and taking measurements, we worked on making a model. Our model includes a summary of our product and the measurements we took, as well as our process for the calculations and measurement taking. We also made several graphs representing the data and summarized the information shown on each graph, as well as a visual representation of each of the steps we took or would like to take to produce our ethanol.
To continue our testing, we would develop a contraption that would be able to separate the alcohol from the fermented mixture using heat. To make ethanol, we would take our fermented substance that now contains alcohol, and we would heat the mixture to separate the water and boil off the alcohol. And finally, we would collect the concentrated alcohol, which is now cellulosic ethanol.
To help further our understanding of the science surrounding our project, we met with many different experts. This included Dr. Janice Louie, a professor of chemistry at the University of Utah, Dr. Kevin Shurtleff, a professor of chemistry at Utah Valley University, Dr. Shelley D. Mintier, a professor of chemistry at Missouri University of Science and Technology, and Jacob Ashman from Spirits of the Wasatch Distillery. All of these wonderful people assisted immensely in our project.
By rethinking how biofuels are produced, we are creating a more sustainable and responsible solution for the future.